Hello everyone! Today we're going to have another example in differentiating an algebraic expression using the power rule. If you did not yet watch my first video for example 1, I will put the link in the description box for the example 1, still using the power rule. Before we proceed with our example, let's have a review on what is the derivative of x to the power of n or the power rule. When we speak of the power rule tells us how to differentiate expressions of the form x to the power of n. If there's a function in which there's an exponent, like for example, we have x to the power of n, so to differentiate that one, we're going to use the formula n times x raised to the power of n minus 1. To apply the given formula, let's differentiate this given function. So we have y is equals to 3x to the power of 4 minus 2x plus 1 divided by square root of x. To answer this easily, we're going to transform the given function into an exponent form. To transform square root of x into an exponent form, we need to recall some rules of radicals in algebra. Recalling the rules in radicals way back in our algebra, so if we have the nth root of a, if we want to transform that one into an exponent form, so the index number becomes the denominator of the exponent. So in this case, in our given, so the index here is n. So if we want to transform the nth root of a into an exponent, so it will become a raised to the power of 1 over n. So 1 because our exponent of a here is 1, then the index will become the denominator. So in this example, so the index is n. So that's why it becomes a raised to the power of 1 over n. We also have to recall the exponent rule in algebra, in which if we have a fractional form, let's say for example 1 over x raised to the power of n, if we want to transform that one in which it will not involve a fraction, so it will become x raised to the power of negative n. So it will have a negative exponent. If you find this video helpful, please consider clicking the subscribe and like button to show your support so that I can make other videos like this. Applying this concept to our given, so we can rewrite y in this way. So y is equals to copy the numerator, so 3x raised to the power of 4 minus 2x plus 1 multiplied by square root of x will become x raised to the power of 1 half. Then to convert it into non-fractional form, so the exponent for square root of x will become a negative exponent. So that's why we're going to multiply the numerator by x raised to the power of negative 1 half. We're going to distribute x raised to negative 1 half to 3x raised to the power of 4 minus 2x plus 1. So first is multiplying 3x to the power of 4 multiplied by x raised to the power of negative 1 half minus 2x multiplied by x raised to the power of negative 1 half. Then plus 1 times x raised to the power of negative 1 half. To simplify this part here, we're going to recall the multiplication rule of exponent. In the multiplication rule of exponent, if we have x raised to the power of m multiplied by x raised to the power of n, so we will just add the exponent. So this will become x raised to the power of m plus n. Applying this concept, we have for 3x to the power of 4 multiplied by x raised to negative 1 half, we have 3x raised to the power of 4 minus 1 half. Minus, so for 2x times x raised to the power of negative 1 half, we have 2x raised to the power of 1 minus 1 half. Plus, we will just bring down x raised to negative 1 half. Simplifying 3x raised to the power of 4 minus 1 half, we have 3x raised to the power of 7 over 2 minus simplifying 2x raised to the power of 1 minus 1 half, we have 2x raised to the power of 1 half plus we will just bring down x raised to the negative 1 half. Now we're going to use the derivative of the n power, which is the derivative of x raised to the power of n with respect to x is equals to n multiplied by x raised to the power of n minus 1. Differentiating 3x raised to the power of 7 over 2, we have first to write the constant, which is 3, multiplied by the n, so which is 7 over 2. Then copy the variable, which is x. Then raise to the power of n minus 1, so we have 7 over 2 minus 1. Simplifying this, we have 21 over 2 x raised to the power of 5 over 2. Next is we're going to differentiate negative 2x raised to the power of 1 half. First, we're going to write the constant, which is negative 2, then the n, which is 1 half, then copy the variable, which is x, then raise to the power of n minus 1. So since our n is 1 half, so that's why we have here 1 half minus 1. Simplifying this, we can cancel out 2 because they are common. Then x raised to the power of 1 half minus 1, so we have negative 1 half. That's why the final answer is negative x raised to the power of negative 1 half. Differentiating x raised to the power of negative 1 half, so we're going to use still the formula n times x raised to the power of n minus 1. So our n here is negative 1 half. Then we're going to copy x, which is our variable. Then raise to the power of n minus 1. So since our n is negative 1 half, so we have negative 1 half minus 1. Simplifying this, we have negative 1 half x raised to the power of negative 3 over 2. From our computation a while ago, we have the derivative of 3x raised to the power of 7 over 2 with respect to x is equals to 21 over 2 x raised to the power of 5 over 2. For the derivative of negative 2x raised to the power of 1 half with respect to x, so we have negative x raised to the power of negative 1 half. Then the derivative of x raised to the power of negative 1 half with respect to x is equals to negative 1 half x raised to the power of negative 3 over 2. Thus, our derivative of y with respect to x is equals to 21 over 2 x raised to the power of 5 over 2 minus x raised to the power of negative 1 half minus 1 half x raised to the power of negative 3 over 2. To convert this in a form in which we doesn't have a negative exponent, so we're going to use the formula we have discussed a while ago, in which if we have x raised to the power of negative n, to convert that into a fractional form, so we have 1 over x raised to the power of n. Applying this to our equation, we have the derivative of y with respect to x is equals to, here we're going to bring down 21 over 2 x raised to the power of 5 over 2 minus, we're going to convert x raised to the power of negative 1 half into a fractional form. So we have 1 over x raised to the power of 1 half. Then minus converting 1 half x raised to the power of negative 3 over 2. So we have 1 over 2x raised to the power of 3 over 2. So this is now our final answer. If you have some questions or clarifications, don't be shy to write your questions down below. That's all for today's video. I hope you learned something from this. Thank you for watching. Goodbye.